In this lesson, we're going to look at the difference between empirical formulas of a substance and the molecular formula of a substance. Now, the empirical formula is the simplest whole number ratio of atoms present in that substance, whereas the molecular formula is the actual number of atoms present in a molecule. Now, these two formulas are not always the same. For example, here we've got three substances that you may well be familiar with. This white powder is called glucose. Here we've got ethanoic acid, also known as vinegar, and formaldehyde, which is a nasty chemical used to preserve dead organisms. And the molecular formulas for each of these substances is, well, glucose is C6H12O6, ethanoic acid is C2H4O2, and formaldehyde is CH2O. Now you'll notice that the carbon, the hydrogen and the oxygen in each of these three substances are in the same ratio. There's always twice as many hydrogen atoms as there are carbon atoms, and there's always the same number of carbon as oxygen. So although their molecular formulas are different in each case, their empirical formulas are in fact the same, because the empirical formula is the simplest whole number ratio of atoms present. And in each case, the empirical formula is the same. It is the same formula as that of formaldehyde. So we can say that the empirical formula for glucose is CH2O, and the empirical formula for ethanoic acid is CH2O, and the empirical formula for formaldehyde is CH2O. So they all have the same empirical formulas but different molecular formulas. Okay, let's look at how we can calculate the empirical formula of a substance. Supposing I wanted to find out what was the empirical formula of copper oxide. Okay, I know that when I take copper powder, right, that's fine copper powder, and I heat it in the presence of oxygen, then a reaction will take place and I get this fine black powder. Now, if I want to find the empirical formula for this copper oxide, then what I'm going to do is I'm going to measure the mass of the copper that I started with. Okay, and I do that and I find out that I start with exactly 10 grams of copper powder. Now, I know that the copper powder is reacting with oxygen in the air, and so the copper atoms combine with the oxygen to form this new substance. I measure the mass of the new substance and I find that to be 12.51 grams. Okay, so we now know that this 12.51 grams of copper oxide contains, or is made from, 10 grams of copper atoms, and the mass of the oxygen atoms present in the substance must be the difference between these two numbers. So there must be 2.51 grams of oxygen. So what we need to do now is to find out the number of moles of copper and oxygen atoms present in our 12.51 grams of copper oxide in order to determine the empirical formula. So we can say that, as usual, 1 mole of copper atoms weighs 63.5 grams. But here we're doing copper first of all. Okay. Then we ask ourselves the question, how many moles weighs 10 grams? That's the mass of copper that we've got present in this powder. We cross multiply and that gives us 63.5x is equal to 10, which gives us x is equal to 10 divided by 63.5, which is equal to 0.157. Now we do the same thing for oxygen. Okay, we know that 1 mole of oxygen atoms has a mass of 16 grams, Therefore we ask ourselves the question, how many moles will weigh 2.51 grams? Okay, and cross multiply, that gives us 16x is equal to 2.51, so x equals 2.51 divided by 16, which is equal to 0.157. Lo and behold, they're exactly the same number of moles. So we can say that the number of moles of copper present in this powder is exactly the same as the number of moles of oxygen present in the powder. So we can say that the empirical formula, which is always the simplest ratio of the atoms present in the substance, is Cu1, that's one atom of copper, to one atom of oxygen. In other words, it's CuO. Let's look at a more complicated situation. Supposing instead of finding the empirical formula of copper oxide, we're going to find the empirical formula of aluminium oxide. So we're going to do exactly the same thing as we did with the copper. We're going to start off with our aluminium powder. We're going to burn it in oxygen, okay, until the powder is completely burnt, and we're going to end up with this fine white powder of aluminium oxide. What we want to know is, what is the formula of this aluminium oxide? What is the empirical formula? Well, let's just supposing that we start with 27 grams of aluminium, just to make life simple. You'll see why in a minute. And we end up with 51 grams of aluminium oxide. So that tells us that in this aluminium oxide there must be 27 grams of aluminium atoms, and well, there must be the difference between these two figures must be the mass of the oxygen atoms present in this substance. So oxygen will be 24 grams. Okay, so as before, what we now need to do is to translate these masses into the number of moles of aluminium and oxygen present in the aluminium oxide. So first of all, we'll do this for aluminium. Well, in this case, this is easy. We know from the periodic table that 1 mole of aluminium weighs 27 grams, so we don't need to do any calculations here at all. We can see directly that if we've got 27 grams of aluminium, there must be exactly 1 mole of aluminium atoms present. So we can write here 1 mole for aluminium, and then for oxygen, well, we know that 1 mole of oxygen from the periodic table has a mass of 16 grams. Therefore, how many moles, we ask ourselves the question, is 24 grams. That's the amount of oxygen present in our sample here. And we cross multiply 16x equals 24 times 1. Therefore, x equals 24 divided by 16, which is equal to 1.5 moles. So we have 1 mole of aluminium atoms to 1.5 moles of oxygen. So we cannot write the empirical formula like this. We cannot say that the formula is aluminium 1 to oxygen 1.5, because remember that the definition for the empirical formula is the simplest whole number ratio. So we've got to change these to whole numbers. We can't have decimals here. So what we're going to do is multiply each number by 2 to get rid of the 0.5, and that gives us aluminium 2, oxygen 3. That is the simplest whole number ratio. So the empirical formula for aluminium oxide is Al2O3.